Welcome to my talk, Big Data and Data Science in the Browser. My name is Yves. I'm founder and managing partner of the Python Quants. I'm German. We are a German company. We have also a company in New York. So, oh well, that's gone already. I've seen already quite amazing applications of big data technology. I don't know why it vanishes all the time. Today, what I will talk about is more or less like how we can interact, how we can deploy, how we can deliver big data technologies or data science technologies in general to the masses in the end, actually. Before I start, a few words about myself. I call myself a Python entrepreneur. I founded the Python Quants, as I mentioned before. He recently launched Data Park with the slogan Data Science in the Browser. And it's actually what I will talk about today. You will see later on what is meant by Data Park. I'm a quant and lecturer, so I did my PhD in math finance. I work mainly for the financial industry. Data Park is also an outgrowth of what we have been doing in the financial industry. What has started out as the Python Quant platform has become Data Park, but more about that later on. I'm also a lecturer, for example, at the CQF program, which some of you might know. I'm author of Python for Finance books. The one is published by O'Reilly. It came out last year. It sells pretty well for such a niche title. Pretty happy about that. The other one just came out in July in print, actually. Derivatives Analytics with Python is much more quantity. This is all about math and only has Python to illustrate how it works. And the next one is in the making. It's called List of Volatility and Variance Derivatives. Even a little bit more technical, but lots of Python in it, you see. This is what defines what I work on, Python and finance. Another very important part for what we do at the Python Quants are events, trainings, and conferences. We started out last year in New York with the For Python Quants conference. Already for the first event, we had more than 220 people attending in Midtown Manhattan. This year, we had already one in New York, and the next one will take place at the end of November in London. What I'm running is a meetup group which I think is the largest of its kind in the world. It's called Python for Quant Finance in London. We are close to 1,000 members. If it's not kind of summer holiday period, I don't know why it vanishes all the time. If it's not for the summer holiday period, we have monthly meetups and usually more than 100 people in attendance. What we just designed together with Fitch Learning, which will take place for the first time in October and November in New York, is a Python for Finance certification, allowing people who are interested either to get in there or already working in that space to get kind of a formal certificate for their skills, actually. But let me come to the topic. Open source, I don't know, anybody? It's kind of a random thing here. Usually you would think that technology is deterministic, but obviously it isn't. Open source data science. I don't know what to do. It takes quite a while. Maybe it's too slow transmission. I don't know. Data analytics. We have seen it a lot already today or heard about it. Companies are investing money in data science, in big data initiatives. And what more or less makes it the success or not is how you deploy technologies. It's not that you have kind of your pet projects or your prototypes that you've built. In the end, it's all about deployment. How you get it up and running and how you get the results. We saw results in the talk before in terms of real money that you say. Others might count it differently. But deployment is on a path to results. I think the most important thing in deployment is what I will focus on today in what I'm talking about. What megatrends influence data science, at least from my point of view, and again, my background is mainly in the quant finance space, but I think these all apply to data science in general. First of all, coding has become social with GitHub. GitHub has become kind of, in some areas, even kind of a CV where potential employers have a look at what other developers have been doing, or you see the complete history of open source contributions of freelancers, for example. So it has become social, and I think meetup groups have made it even more social. I always get good feedback from people when they attend my meetups, because they say, well, in my company I'm the only one working in this particular space. When I come to the meetups, I can speak to other people who are doing the same thing. I can ask questions, I can build personal relationships, and I'm not, so to say, constrained to my co-workers, which might not have the same experience as myself, or the same things that they're concerned with. So it's very dynamic these days, and I sometimes ask even people what they have been doing 5 years ago, because I know people, they go to, at least in London, to one meetup after the next. They can go to meetups, I think, in the bigger cities today, every night, if you like. Then we have on the more on the technology side, or let's say on the data side, we have more and more open data sets. When I wrote my PhD thesis, I had to pay for data, even for the smallest amounts of stock prices and so forth. Yeah, it was really expensive. It was 20 German marks I had to pay. Back then, I thought it's ridiculous, actually. And these days, if you're studying finance, you have all the data available, and generally for free. Actually, it's fantastic, I would say. On the other hand, there are trends like moving more and more tasks, moving more and more things to the browser, especially in our space. And Jupyter, from my point of view, and coming from the Python world, Jupyter has been IPython notebook before. It is an outgrowth of the Python universe. It's a fantastic example. At this stage, I want to ask you, who of you have ever used Jupyter or IPython notebook to this end? One, a few, 3 hands. Actually, you will see it in action later on, but from my point of view, it's kind of a fantastic tool, actually. I wrote the O'Reilly book that I showed before completely in IPython notebook, and converted it to restructured tags and put it on, and so forth. So you can not only do interactive analytics, you can do amazing things with this tool, actually. On the other hand, it has become quite common that individuals or even institutions these days store the data in the cloud. Dropbox Enterprise is kind of a good sign, where you can get 1 terabyte of cloud storage for €99 or US dollar per year. And it's very easy for people today to use the cloud. It was mentioned in the keynote this morning in the other room, actually, that back then cloud was something special and nobody got the idea, and today's kind of common thing to use cloud-based applications like Dropbox and so forth. On the other hand, you get compute power from DigitalOcean or Amazon or you name it, built by the hour or even by the minute sometimes, where you can easily scale up whenever there's a need. This makes it possible that even smaller companies, and currently I'm in San Francisco, and I yesterday spoke to a founder of a very small startup that just recently started out. It's a very data and compute intensive startup that they founded, but with 2 people only, they can easily scale up today. So there are no limits, so to say, to what you can get from the bigger providers when it comes to either storage or compute power on the other end. But how many people are active in this field? I found a few numbers in this regard. This is not actually a real Venn diagram, but I just wanted to illustrate how big the groups are. So you see there's lots of overlap in there. It's estimated that there are about 45 million people consider themselves or are considered programmers in the world. 10 million, more or less, of them are technical computing programmers or in the technical space, and 5 million people are assumed to use Python these days. Again, the most important language for what we are doing, actually. So you see that quite millions and millions of people who are using open source technology, but also other technologies. But the question is more or less how to bring the nice things that we see here at the conference to these people in a very easy, efficient, and maintainable way in the end. When it comes to languages, what do we see in the market? We see that more and more open source languages dominate the data science scene. If you go back 10 years from today, I think this chart would have looked quite differently. But today, sorry, what does it do here? Oh yeah, this is when you have too many things connected. Oh, I'm sorry. Here we go. But today you have these very famous languages like R, obviously in data science. There's no way around R from my point of view, even though I'm a Python guy. Python comes second when we speak about open source languages. SAS here is a commercial solution in between, and SQL, I mean, it's kind of a hybrid. It's not really a data science language. but it's a technology that is A, open source, and B, fits very well into the R Python sphere here. Why do I highlight Julia here? In our space, in the quant finance space, it has become really popular because it's, for example, pretty close in syntax to Python. So once you master Python, it's pretty easy to go to Julia and to write code there, but it's much, much faster. So you can implement, let's say, high-performing applications easier than typically with Python, and it's the fastest growing here. So although there's only small amount of usage here, it's the fastest growing not only open source language, the fastest growing language in this space here, given the statistics of this poll actually. But as generally no, let's say either or, MINR user, MIN Python user, what you see when you go out is that more and more people are using multiple languages to reach their goal. It's not enough to work with only one technology. I recently had a project for a German big company, a DAX 30 company, where I couldn't find anything appropriate in terms of statistics in the Python world, but it's really easy to go from Python to the R world. What we did is kind of more or less build a pipeline where we got the data into Python NumPy array objects. We put it then into the R runtime and got the statistical results back into Python. So there's no need to say either or. It's pretty easy in this open source world in general to combine certain technologies with each other. But when it comes to deployment, this doesn't make any easier. I mean, if you today install, for example, Anaconda, which I think is right now the most popular Python distribution, this comes along with like 3 gigabytes of storage that you need only for kind of a very basic Python installation. Then you put R on top, then you put other things on top, and it grows and it grows and it grows. And when you then think, for example, of a big financial institutions where maybe thousands of people use these technologies, then deployment really can become a mess for those, and a nightmare actually for those who have to take care of it. Therefore, there is actually this big problem. It's actually not a single problem in itself. It's a multifaceted problem. We have many things to consider when it comes to the application of open source technologies in a data science or big data space. The most important one, from my point of view, again, is in the middle here. It's deployment, but we have others. Open source is by itself a fast-changing environment. There are hardly ever well-established vendors or partners that can help you out with open source technologies. This might differ really from technology to technology. But for example, in the Python space, only recently a few companies have grown up that can support you well here, like Continuum, for example. Libraries, there are so many libraries, even in the Python space. I discover regularly libraries where I'm really amazed by what they can do, but I haven't been aware of them for maybe months even. So there's so many things that come out, and some people don't even notice, even if they're active in the space. Maintenance, how to update, how to maintain the infrastructure. You have also diverse end users. Think of this Anaconda distribution, which comes along with kind of 200 libraries. When you let kind of only a domain expert install by himself such a huge package, it can become really risky to let him alone with this kind of big installation where support can get nightmares actually when something goes wrong and the whole thing falls down actually in the end. But again, my talk will focus on the deployment side, which by and in itself I think can solve more or less all of the other issues. That is, well, when you get the deployment right, then it doesn't matter which kind of end users you're facing. When you get the deployment right, maintenance should also be easy and should be efficient in the end. When you get it right, maybe the role of the vendor or the partner isn't that important in the end, but we will see what we can do in this regard actually. So let me come to kind of the solution, data science in the browser. The solution from my point of view with most open source technologies, at least when it comes to the interaction with the open source technologies, is to present and to provide them via browser-based technologies. Which means the deployment of something like a Firefox browser or a Google Chrome browser should be solved satisfactorily for every IT department. You find it no matter what company you go in, no matter what desktop notebook, whatever you see, you find this particular tool where you get into. And I mean, there's so many cloud-based solutions today that has become kind of a common standard. And why not use the established technologies here to provide access to the wonderful open source data science technologies that are there today? And from the delivery standpoint, I mean, everything is there. We have fantastic Linux-based infrastructures, and we have, thank God, Docker these days, where we can easily ship any kind of package. And when you think of kind of having a Python-based installation and maybe an R installation, maybe X, Y, Z, you can package them neatly together in a single container and ship them at once. And this makes it really, really easy. And I think the numbers of Docker deployments speak for themselves. You can read these articles where companies report from our experience from the last 300 million Docker containers that we ship, and so forth. So it has become a very reliable, scalable infrastructure that you can use to this end. What we have been focusing on is not to reinvent the wheel. And I myself, I'm a martial artist. I'm doing martial arts for more than 25 years, and I really like this quote from Bruce Lee. To absorb what is useful, to discard what is not, and to add what is uniquely your own. So we don't, with what we do actually, we don't try to reinvent the wheel. I've seen many, many initiatives which I think try to solve similar problems, but which started from scratch and tried to build everything that was already solved, so to say, to solve anew and to establish new standards. I think this is not necessary. The major pillars that we need to achieve the goal, at least that we have in mind, are already there. And the result is what we call Data Park, and it's reachable. This is actually the URL, datapark.io. It's a comprehensive toolbox for data scientists delivered via the browser based on scalable infrastructure. I will show an example using Dropbox later on, using Ubuntu, using Docker containers. We're providing Python, Julia, of course SQL technologies, R, and of course I would say powerful set of tools and technologies like Plotly. Plotly, kind of very powerful language agnostic plotting engine which allows to generate quite easily nice looking interactive graphs. Who of you is using Plotly already? Who of you have ever heard of Plotly? Oh, you should go to the, I don't know, how's the website called, the Open Data Government page from the US. One of the plotting engines there is Plotly already. So you will see my example actually is based on Plotly. So maybe you grasp it immediately when I present the result. And why I'm putting it here on more or less the tool side is that it works really together with Python, R, JavaScript, you name it. You have excellent integration back and forth. So there are many, many ways you can use Plotly to generate easy and nice looking plots actually in the end. What we have been focusing on is actually on a side that is typically neglected. It's the user management. What we add is kind of a sophisticated user management, but even here we are not trying to reinvent the wheel. What we use is kind of the Linux as the basis in that sense, because this has been developed over decades and is well established and is known to be secure, and I think you can reinvent what they have been doing over decades. Why I'm stressing this point is that typically when we see kind of similar projects where they start from the tooling side in the browser, they come from top down. And this kind of, I recently had at one of my conferences a speaker from Quantopian. This is kind of a startup in our quant space. They allow, let's say, regular people to implement algorithmic trading strategies and to backtest them on the platform. And they recently introduced IPython, a notebook on the platform, or Jupyter these days. And where they say, well, we can't allow them to do this or that or this or that because there are security issues there's here and there. And it was exactly the thing that we addressed from the beginning to say, well, we start from bottom up. It's kind of the whole infrastructure we use. We don't come from kind of a front-end perspective. The front-end is, of course, what we're working with, but we have to get the rights and roles right first, and then we can build on top of that. So this is something we stress what we do. And it makes it quite easy for companies, institutions, I will mention examples later on, to easily and to quickly not only deploy, but also to introduce it into organizations or larger groups actually in the end. We don't try to reinvent the wheel. This also means that we set on established standards. We allow easy in, easy out, and it can be fully integrated. There's not a single kind of, let's say, file format that we have invented, where people say, well, when I start working with your data park platform, there's kind of a vendor lock-in, and I can't get out later on. It's not at all the case. So you can easily upload, download, or even work on a Dropbox. I will show this example later on. You have multiple sharing options. We even recently installed something where you can say zip all and download a zip file, a zip dump of everything that is under your account, and you can close it and you're done. So it's not that we try to lock in anybody here with the platform. What we had in mind when we started out is to generate something. It was inspired by me visiting the High Performance Compute Center in Jülich in Germany, where they showed me the most recent generation of high performance computing. I mean, I've seen computers there with kind of 2 million cores, and they had 3 of them in a single room. This is what high performance computing is about. And when we think back, the first generation indeed was kind of to move the data around. Back then, even me being a teen, I moved around with diskettes and got new games and so forth. Or think of the days when CDs were shipped with updates for certain subscriptions that you had and so forth. Then they came up with, okay, we can code locally, but we ship the code and deploy it wherever, on the server or someplace else. What we have in mind with our data park and with the possibilities that the container technology allows us is that we don't want to move anything. So whenever we start working with a new client, be it on a newly established infrastructure, on their established infrastructure, on-premise, in the cloud, or wherever, we bring all the toolbox and everything that we have to the place where the data sits and where the code is. So we, on the same infrastructure, we do the coding, we have the data, and we don't leave the infrastructure, and kind of the window where we get to all the things that we need to get to is kind of the browser here in that sense. Actually, when I will show the example later on based on Dropbox, this is kind of it doesn't fit really in this third generation picture that I want to paint here, but I will comment on that later on. So in the end, we have our platform, which looks like this, but you will see it in action in a second. And we try to bring the best of open source together in the browser. This means in the end that for an individual who just wants to try out, you register. I think it might take 30 seconds, and you have everything you can use in the cloud. At the moment, we don't charge anything for the platform for individuals. What we charge for is kind of for clients, for corporations who want to use it on-premise, who want to have their own installations and so forth. But when it comes to on-premise installations, there are, of course, things that you have to consider. First of all, at least when it comes to this big data analytics survey, it's integration. And I mentioned it before, we open in all directions. We only use standard technologies that can be integrated anywhere and with everything. Security, again, we built on Linux, and we can also kind of connect to the existing security things like LDAP and so forth. Ease of use, again, we don't reinvent the wheel. Jupyter is used by millions these days. There are tens of millions of Jupyter notebooks out there that you can use. It's only standard, and we don't want to establish something new when there is an excellent tool already out there. Scalability, again, what we use is Docker. It's all cloud-based, so scalability usually is not an issue. So I think we at least we address all the typical criteria that people might have in mind when looking for such a solution. So what can we do with it? Just a few simple use cases. Deployment, I said, to deploy the whole thing, R, Python, and so forth, might take 30 minutes on any kind of infrastructure whenever Linux is installed. And from the 30 minutes, it's more or less 15 to 20 minutes, depending on the line in between, is downloading the Docker image. But then you are done. That's it. Think of deploying Python or whatsoever across smaller teams like 5 to 20 people, or even across an organization where 500 people might want to use it. Analytics and sharing, obviously we can work in the browser, we can use whatever kind of infrastructure. We make use of what we have in form of Jupyter notebooks, public folders, email functionality. Think of social coding, but indeed coding in the coding sense. GitHub is more or less kind of a static thing, where you deposit something, you can watch it, you can clone it, but it's static. Think of Data Park, kind of an interactive execution environment in the same sense. You have your things stored, but you can watch them, you can change them, you can edit them, you can work with them, and you can publish and view them actually. Publishing will be my example. I will show this in a second. Analytics as a service, this is, I would say, as of today, the most successful use case that we have. Notebook hosting, I will come to that actually also in a second. Web app deployment, we don't stop there when it comes to kind of prototype, interactive analytics or whatsoever. On the platform you can deploy whatever you want to deploy. So it's not only restricted to have kind of interactive notebooks or whatsoever. You can work on the infrastructure as you would be working via SSH access, you would deploy, ship things, and so forth. Shipping a data science toolbox, I was even, or actually I'm still in talks with one of the biggest management consulting companies in the world. Because when they say, when we come to clients typically, and these days they more and more do highly sophisticated data work as well, obviously, they say it's such a mess that we get sometimes terabytes of data and we have to ship that. I said, well, the solution is not to get the data. Also, from the viewpoint of data protection, security, and so forth, the solution might be to bring the tool set to where the data sits and to get you access via the browser, via standardized technologies to the data, and to execute your analytics where the data sits. I said, well, this is kind of amazing. Think of it kind of these days when due diligence teams came to big companies and they said, well, I need this kind of, I need this, bring me this and that. These days you just bring it there, you connect to it, you get access, and then you do your analytics in a very standardized and very efficient way. Specific things I want to mention and point out is teaching programming and data science. This is actually where we started to use the platform for teaching programming and data science. So for all the things that we do with Fitch Learning, we use the platform. Sometimes when we have large groups, like this year in New York, we had per day more than 50 people working on the same platform. We just spin up a new instance in the cloud, put it on there, and we had our 50 people working. And later on, when we were finished, everybody could get their stuff out, and we closed the instance. Again, they could move their stuff to now the regular platform, for example. So this is kind of very, very nice thing. We recently introduced it for the first time on a bigger scale at the university, where a group of 60 students was taught programming or a certain class based on Data Park, actually. They got their own instance. This was an on-premise installation. We shipped our Docker container on their cloud-based virtual machine at the university, and they used it for their class, and they will use it, or they will use it in the future now in more and more classes as they go. Analytics as a service, as I mentioned before, is, I think, the most successful case that we have. That in a sense, when you have your IPython notebooks, your Python code, or whatever you have, and you put it on GitHub, and people clone it, there is no guarantee that they can execute it. And then they sit there and say, well, it's Python 2.7, Python 3.4, and I'm missing this library, and this library is missing, and this and that, and here and there. What we can provide is, in the same way as you can host your code on GitHub, that we put it on the platform, but we can guarantee that once you have executed it on the platform, everybody else can execute it on the platform. So we built, for example, an offering for Eurex, our German derivatives exchange, where we had Python-based tutorials, and all the code and all the Python notebooks, Jupyter notebooks, are hosted in the cloud on our solution, and people log in, a very simple login, and they have everything. They just click on it, executed. There's no question about which library, which version of this and that, and I'm not an expert in it. But the most successful example is my book, my O'Reilly book, Python for Finance. We have more than 1,000 registrations on the O'Reilly account for people who want access to the notebooks accompanying the book. So I don't want to think of kind of the support things when they write me emails. Well, I cloned your repository, I can execute it, and I have a few that try. I have the GitHub repository out as well. And there was this guy, well, I cloned it on Windows 3.4 Python, and I said, well, I never tested it on Windows, and it's for Python 2.7. Please go to the platform, there you click, and you can execute it. Actually, this is what we had in mind when we established that. Now I want to come, let me have a look at there. I have actually enough time left to show you the example, to show you kind of a live example. This is very simple. This is all about big data, but I think it shows actually how it works in principle. So I go to my browser, and if the internet connection is fine, I should be able to log in here and make this a little bit bigger. So I'm now on the platform. What I want to do is to show here is my Dropbox account, and I have generated a new folder for this example. It's called Big Data, and in there I have a very small data set, a CSV file, and I have an IPython notebook. So what you will see now will be based on a notebook and the data set, which are both stored on Dropbox, and nothing is stored on DataPark at all. But my DataPark account is connected to my Dropbox account, so I can navigate to this particular thing. So I'm now here on the left-hand side. You see I'm here in Home, my Dropbox, and I'm now in the same subfolder. And you see this file, and here on the left-hand side, I only get displayed the notebooks, actually. I can open them. I will now close it to see what's going on. This is the notebook with the code cells, and I have now executed. You see these two cells. I've imported a few things. I've signed in to a demo account for Plotly. And here you see what I'm doing is I'm reading the financial data from my Dropbox account, actually. Here I define the path. The next thing defines the file name. And this with Python reads the CSV file. You see this is very quick. What I can now do is to plot the data. And this is now done with Plotly. For those of you who have never used Plotly, and if you have anything to do with interactive analytics, you see it's a single method call on a data frame. And I have here in my notebook an interactive D3GS plot, which typically, if you would program it directly, would take I don't know how many lines. You can do all the nice things like zoom in, zoom back, and so forth. You can do even more stuff like having a linear regression line put into a data set. So here you see this is just a parameter that I pass into the method call, best fit true. Provide the colors, and again I have a nice looking interactive graph here, which I can also use for different things. Now I want to stay on the Dropbox. Again, no vendor login. I'm on the Dropbox. I'm just using this as an execution environment, and I'm now retrieving this plot and saving it to the Dropbox account. So when I now go to the Dropbox account, it should display in a second. What I will show you to save some time is, now that we have executed this notebook, I can, for example, go to the file manager. What we can do here is, here you see, here in the file manager you see that there is a new file generated. But what I want to do is to publish this notebook. We do this, here you get the URL where it has been published. But let us have a look here to the Dropbox. The internet connection is not the fastest, actually. what you see here, now I have my example for Global Big Data Conference on my public notebook site. And this is now published, as you can see here, as an HTML, which is now static. This is now static code. I can't do anything with it. But you see the nice interactivity remains. So for example, if you have internal reporting purposes or whatsoever, or you want to publish kind of a research report that you want to share with the world, it's pretty easy. It's just a single click and you can publish and share it with the whole world. And people, once you have published it, can then download it to their local installation, or what you can do with the data park thing is, for example, that you can, for example, copy it here, and I don't know what it does, why it always gets back. And you see now I have retrieved the URL and I've copied it from the public area to my personal account. And everybody else who has an account can do the same thing. And you see I've started out here with a data set and code stored on Dropbox. I just executed this code, given a data set on Dropbox, and I got the results. I could publish it. So in all directions, it's all open. And again, this is not kind of a thing that is only possible with Data Park, but Data Park in combination with Dropbox allows you to do all the data science or typical data science tasks in the cloud completely, no matter what infrastructure, no matter what computer you have. So it's pretty easy, pretty simple. And again, the single accounts are free, and we don't have any intention to close them anytime soon, or even to restrict them. Though there's full functionality, there's no restriction to the free accounts. Maybe it's kind of the German technology, why this is not really working and disappearing once in a while. So in the end, what we end up with Data Park is that we have the best of open source for data science, delivered on a powerful infrastructure, Linux, Anaconda as a Python distribution, Docker containers, and much, much more. We have put together, I think, a nice set of powerful tools. What I haven't shown, for example, you have complete shell access. So whatever infrastructure you're working and you want to work on the shell, you can use Screen, HTOP, Git, and whatever you want to use, you can use there. So it's more or less, it's only a tool set, if you like, with some nice additions. So you don't need to SSH from your computer to somewhere. You can even SSH from the browser to your infrastructure. And we have the file manager. We've seen the file manager can do a number, I think, of amazing things. And it's all open standard in the sense that we're using open source and open standards like Python, R, Julia, IPython notebooks, Jupyter notebooks, the Linux file system, Dropbox, and so forth. It's more or less, if you like, a curated collection of open source data science technologies that we deliver in a very standardized fashion. If you want to give it a try, just go to datapark.io, takes 5 seconds, and you are registered. If you want to give us feedback, team@datapark.io. If you want to speak to me, I'm around for quite a while after that, for sure. And that's already it.